Okay, we're going to follow up with another video on transformation of trig functions. This time we're going to be using the second tab, Transformations 2, in this Trigonometry Ultimate sketch. And like the last one where we could change parameters h, k, a, and b, those parameters are going to mean exactly the same thing that they did in the last video. But this time instead of doing them with sliders, we can actually type in values. So I can turn on some axes here, and if I can turn on or off a grid with that. So, for example, if we have sine of x, this one actually shows the formula with the numbers actually in there, and I can type in a particular formula. So let's say if I had, say if that's 2, and b is 0.5, h is pi, pi is, you just type p, pi divided by 4, and k is 1. Okay, and we have there the graph that we end up with. So this is the graph of y equals 2 times sine of 1/2 x minus pi over 4 plus 1. We can show the same reference lines that we showed on the last video. Well, slightly different reference lines this time. This time the box is moving to the right or left with this. So you can see this distance from here, from this point to this point, is the distance is 1 period. Okay, so it's 2 pi divided by b is the period. So it's 2 pi divided by half is actually 4 pi, and so we see that's a distance of 4 pi from here to here. Or from 0 to 4 pi is also 1 period. But this period starts where the sine wave would normally start, at the center line, and then goes up. But however, that center line has been shifted well, up by whatever k is, up 1 unit. So it's at y equals 1 rather than it's y equals 0. So now this maximum is going to occur then at, well, instead of normally, well, let's see, here's the regular sine wave. Instead of normally here at pi over 2, 1, it's been moved all the way over here to 5 pi over 4, 3. Okay, because it's been stretched out, it's been shifted up and to the right, and expanded vertically as well. Okay, and so you can see this maximum value is going to be 3 and the minimum is 1. Those are these sort of lines here that do that, show us that. Of course, if you do cosecant, it's going to hit that sign with the same that version of sine with the parameters. Cosine, you're going to see it affected the same way. So you can see these values. So let's suppose we wanted to graph y equals 3 sine of 2x plus 1. Okay, well, the first thing to notice is we need to factor the 2 out of this. And you want to think of it at x minus a negative 1/2. And if you want, say, plus 0. So we see that a is 3, b is 2, h is negative 1/2, and k is 0. So we can plug those numbers in. 3, 2, negative 1/2, and 0. And so I can put those in. So the amplitude is 3. B is 2, so it's going to be shorter period than normal, half as much. So it's going to have a period of pi. And then what were h and k? Negative 1/2 and 0. So this will put their center line back to the axis, and this was negative 1/2. And so our phase shift is 1/2 to the left. So this distance right here is we shifted to the left 1/2. So HK is that pink point there, and that's going to be kind of where the sine wave starts now, off to the left, or you can think of it as starting when time 0, then it's starting up a little higher than normal. Okay, so we can do these things here. Okay, you can also look at something, and let's say we could take a graph like this. How could we tell what the formula was if we were just looking at the graph? So let's take that in just a minute. Well, you can tell it's either a sine or a cosine transformed, and it could actually be either one. We could transform a cosine to look like this. We just have to have a different amount of phase shift. But let's say we want to make a function of the form a sine of b times x minus h plus k. How can we find these numbers? Well, first of all, we can find the maximum and minimum, and from that we can find both the k and the a. Okay, so if we find the top one we see here is 3, and the bottom one is negative 3. Average those, and that's your k. So let's suppose I have a different k here, like this. So now it's going up and down from negative 1 to 5. So average those. 5 plus negative 1 is 4, divided by 2 is 2, so k is 2. And so y equals 2 is your center line right there. Okay? Now, how can I find the amplitude? Well, find the distance between these. So subtract them. 5 minus a negative 1 is 6. That's a distance of 6. Half of that is 3, or the distance from the center to the top, or from the center down the bottom. That's a distance of 3, so the amplitude is 3. The amplitude is 3, and then the a is either 3 or negative 3. Well, it's easier to see this one. It looks like it's starting a little high, but it's from our normal cycle, we find a place on the center line where it's going up, and think of that's how much we shifted. Well, we could be shifted by lots of different amounts. We could have shifted to the left all the way over to this point here, or all the way to this point, or to the right over to this point over here. But the shortest amount of shift would be just right here. And if we do that, then we can think of that as a positive a. And the amount of shift is just this amount right here, and it's going to the left, so then your k is, your h is negative, so it's going to the left by 0.5 is this distance right here. And so you can we can apply this to a lot of real world applications as well. And so if we have some of those real world applications, we can see these different amounts of changes in here. So again, if we have something like if we had the cosecant that we were looking at and trying to figure it out, what would we do? Well, again, you can find out what this minimum value for y is and this maximum down here, and we know that halfway between that is our center line or average line, and that's, again, you find it the same way. Just average those two y values, and that's going to give you your value for k, the vertical shift. And then this one doesn't really have an amplitude, but it does have an a value. And again, that a value is the distance from the top line there down to here, or halfway between the top and the bottom here. Those lines there, and those lines are, of course, where the minima and maxima occur. Alright, well, then what you do is you find the distance between two corresponding points, let's say between these two minima, or these two maxima, or any two such points that are corresponding. find that distance, and that's the period. And remember that 2 pi divided by that period will be what b is. Okay? Since that's a distance of pi, 2 pi divided by pi is 2, so b is 2. Okay? I think we'll do one more thing here. What about a tangent? Tangent, the only thing different is this distance all the way across here is actually 2 periods. So when you find the distance from one to the corresponding point, that again is the period, but this time it's pi divided by the period is b. Okay, so that's the only slight difference for tangent and cotangent.